Have a nice day, everyone. I hope you are all doing good. Mrs. Janson is back again for another grade 8 math lesson tutorial for the second quarter for week number 2 with the topic Systems of Linear Inequalities in Two Variables. Before anything else, it is necessary for us to have a recall first about linear equation. The graph of linear equation in two variables is a line. The solution of systems of equations is a point. It is the intersection of the two lines. The point of intersection is the ordered pair xy which satisfies both linear equations. At the right are graphs of the systems of equations y equals 2x plus 2, which is the red line, and y equals x minus 1, which is the blue line. The lines intersect at -3, -4, located in the third quadrant. Thus, the solution of systems of equations is -3, -4. Now, let us proceed to our lesson proper, the systems of linear inequalities in two variables. System of linear inequalities is same as system of linear equations. It can be solved graphically, and the line can either be solid or broken line. Solid line is used when the inequality is less than or equal to or greater than or equal to, and broken line is used when the inequality is less than or greater than. In systems of linear inequalities, the solution is either half plane below the line or above the line. Points or set of ordered pairs that satisfy both inequalities. It is where shaded regions of each inequality overlap. Previously, we learned about finding the solution of linear inequality in two variables, and that was our lesson during week 1. Now, let us recall the steps in doing so. Step 1. Write first the inequality in equation form. Step 2. Determine the x and y intercepts or find any 2 points that will satisfy the equation. Number 3. Connect the points by a line or broken line depending on the inequality symbol. Number 4. Choose a test point on either side of the line and substitute to the inequality to determine if which point may satisfy the inequality. And number 5. Shade the regions where the points that satisfy the inequality belong. Example number 1. Find the solution set of the system of inequality. Y is greater than or equal to x plus 3 and y is less than or equal to -2x plus 4. Solution. Step number 1. Write first the inequality in equation form. For the first inequality, we have y is greater than or equal to x plus 3. The equation form is y equals x plus 3. For the second inequality, y is less than or equal to -2x plus 4. The equation form is y equals -2x plus 4. Step number 2, solve for x and y intercepts. In here, we may recall that the x-intercept is the value of x when y is equal to 0. Or it passes the x-axis. And y-intercept is the value of y when x is 0 or it passes the y-axis. For the first equation, y equals x plus 3, we have the points 0, 3 and -3, 0, which are the y and x-intercepts respectively. For the second equation, y equals -2x plus 4, the points are 0, 4 and 2, 0, which are also the y and x intercepts. Step number 3, choose a test point. In here, it is advisable for us to use the origin, where x and y values are both 0 for easy substitution. For the first inequality, which is y is less than or equal to x plus 3, using the point 0, 0 as test point, the solution set is the shaded region at the right. For the inequality y is greater than or equal to negative 2x plus 4, again using 0, 0 as test point, the solution set is the shaded region at the upper right part of the line. Take note that when we say solution set, all the points found on that region satisfies the inequality or makes the statement true. When you graph these inequalities in one coordinate plane, there is a part in their regions that will overlap. The portion where the two graphs overlap is the solution set of the two inequalities, meaning any point on that region will satisfy both the inequalities. Example number 2. Find the solution set of the system of inequality y is greater than x minus 1 and y is less than or equal to negative 2. Solution. So the 2 points for the first inequality, when changed into equation, we have y equals x minus 1. The points are 0, negative 1, and 1, 0, which are the y and x intercepts. And then for the second inequality, y is less than or equal to negative 2, the equation is negative 2. So in here, there is no x-intercept. The y-intercept is 0, negative 2. The test point will be 0, 0 for both the equations. Since the test point is 0, 0, this makes the inequality true. The solution set is the region bounded by the lines of the two inequalities. So that's all for now, and I hope you learned something from this tutorial. Before ending this, so you may answer learning task number 1 on page 10 of your module, and then learning task number 2 and 3 on page 12 of your module. For the assessment tools, so worksheet number 2.1, journal writing 2.1, and assessment 2.1 are all being uploaded in your Google Classroom to answer. So before ending this, let me quote from Aristotle's saying, which goes this way: the worst form of inequality is to try to make unequal things equal. Thank you very much for listening.